first of all, you can just straight up plug this into your calculator and evaluate it. So I want you guys to go ahead and do that. Just plug it in, log 2 of 19, like you normally would, and tell me what you get. And everyone's going to need a calculator anyways, so might as well grab one. All right, so you guys hopefully plugged that in and you got 4.248. Did you guys get that? Yay. All right, so you have to be able to use the change of base formula to actually solve this, because when you get to calculus, it's way easier to do derivatives when you have it as a common log or a natural log rather than written like this, where the base is 2 and the argument is 19. So, for example, let's just say I wanted to solve this. I have log 2 of 19, and I was like, oh, what does that equal? Well, it equals x. Okay. The next thing you would do to solve it algebraically is you would exponentiate this. You could be like, all right, I'm going to make this to this power, so exponentiate, and that cancels, and I get that 19 is equal to 2 to the x. And then there are two ways to solve from here. You can common log both sides, or you can natural log both sides. Let's say I common log both sides, meaning there's a base of 10 here that you don't see. And be sure you squeeze the log into the front, right? Because you're taking the log of that. So then I get log 19 equals log 2 of x. Okay? And to solve this, I can actually just divide by log 2. So that x could be in the front here if you wanted to move it to the front, but I've got like a little base of 10. Because I common logged it. So I can actually divide by log of 2 and divide by log of 2 where I solved for my variable. Now, you're not going to have to do all this work, but what you want to do when it says to solve it by using the change of base formula and use common logs is literally you're going to write, okay, I know I've got this, and that is equal to log 19 over log 2. Notice the base goes in the basement. Get it? All right. And then we can plug it in like this with a base of 10. And I want you guys to go ahead and do this on your calculator. You can actually leave this guy blank, and it knows that there's a 10 there. Okay? So when you plug it into your calculator, plug in log 19 divided by log 2 and leave the little base blank. Or if you really want to plug in a 10. So the other way you could do this is with a base of e, meaning take the natural log. So I could go through this whole thing, but instead of doing the log here, I could take the natural log. So what's the only work you actually have to show when you're doing this? So the problem will say, what does this equal? Use base e. So instead of doing common log, we're going to use for base e, the natural log. So I would like to see this work. The ln of 19 over the ln of 2. So the little base, same thing, goes in the basement. And everyone plug that in too and see if it's the exact same thing on your calculator. Go ahead and try it. Ln of 19 over ln of 2. All right, so hopefully you got 4.248 and 4.248. So when you do these problems, this is the only work you have to show. All right, base 10, you do it with logs. Base e, do it with natural logs, and you got your answer. This is called the change of base formula, and this will help you in calculus because it's easier to take the derivatives of the natural logs or the common logs, okay? All right, now we're going to solve some challenging log problems. So solve logs by ensuring that the arguments match. So right now, this one has an x in the argument, or an x squared in the argument, and this one has an x. People make the mistake of thinking this is the same thing, but this is only squaring the x. And on the right-hand side, it's squaring the entire thing. So that is different. All right, so they're not the same. So the first thing I can do is I can move this exponent into the front, and I get 2 ln of x. And I can also rewrite the right-hand side. I'm squaring the entire thing, so this is the same as the ln of x times the ln of x, because I'm squaring the whole log, not just the x. So technically now what I did is I made the arguments match. Every single argument is x, x, and x. Okay? So that's step 1, make the arguments match. Step 2 is going to be set it equal to 0 or get everything on the same side. I'm going to write same side. So I'm going to subtract or set it equal to 0. I'm going to put 0 on this side. So I'm going to leave this as the ln of x times the ln of x, but I'm bringing this 2 ln x over, so I have a minus 2 ln of x. All right, you can't combine those or subtract or anything. So the next step on these will always be to factor tractor. All right. So it's just a GCF on this one. What is common on your two terms right here? What could you factor out? An ln of x. All right, so I'm going to take out an ln of x, and that leaves me with one of them here and just a 2 here. Now if you're factoring, you set them equal to 0 and solve. So your final step is to solve. So I'm going to set this natural log of x equal to 0. And I'm going to set this set of parentheses, ln x minus 2 equal to 0. And in order to cancel the ln, we exponentiate by taking the e of both sides. What is anything to the 0 power? 1. All right, and over here I'm going to add 2 first. And then I'm going to exponentiate using the e. And I get e squared, which is like 7 point something. Okay, yeah, there you go. Whatever you got on your calculator. So the first step is sometimes the hardest step, to make them all have the same argument. Okay, argument is this little guy right here. So again, these do not mean the same thing on number 3. What I can do is I can rewrite the left-hand side. I could technically rewrite both of them, but I'm only going to rewrite this side. And instead of the square root, what power can I write that to? Yeah, 1/2. I'm going to leave this side for now. You could do one big parentheses around the whole thing and put it to 1/2 if you wanted to, right? All right, so what can I do with this 1/2 power now? Right, just like I did with the 2, I moved it to the front. You have to move it to the front so that I can make arguments match. So I've got 1/2 log x, and I'm going to leave the square root of this whole entire log here. All right, I can get rid of that square root on the right-hand side by doing what? Yeah, I can square this entire thing, and it will undo the square root. That also means I have to square this entire thing. I'm going to go ahead and square the 1/2 and make it a 4th. But I have to keep this whole entire log squared. Just like I had this entire ln squared. If I wanted, I could write this as 2 logs of x, right? And on the right-hand side, this canceled, and I just have log of x. So I made my arguments match. Wow, everyone's sick. And on the right-hand side, I got rid of the radical. The next step is to get everything on the same side, okay? So whatever way you want to do it, I'm going to move this guy over, so I'm going to set it equal to 0. So I still have a 1/4. And if you want to write this as log x times log x, you can. Or you can do that. Minus log of x equals 0. So now we have a GCF. So Harrison, what can I factor out of both terms? Yeah, log x. And Evan, what's left right here if I factor out a log x? Yep, 1/4 log x. And right here, if I take out a log x, Stella, what's left? Yeah, very good. All right, so now I factor tractored. I can set each piece equal to 0. So log x equals 0. And this part right here, 1/4 log x minus 1 equals 0. So this one's log x is already by itself. We're going to exponentiate by doing 10 to that power. And so I get 10 to the 0, which is 1. On this side, I need to add 1 first. And then I need to multiply by 4. And then I need to exponentiate. So I do 10 to that power. And x equals 10 to the 4th, or 10,000. All right, solve by exponentiating or logging. I like this first one. This is a good one. All right, you guys. So I can get rid of the logs by exponentiating. So Miranda, what do I exponentiate by on both sides to start? Yeah. So like there's really a base of 10 here, but there's also a base of 10 here because they're both log base 10 since you can't see it, right? So I'm going to go ahead and do 10 to that power and 10 to that power. Now, does this 10 that I just did cancel both logs? No, it only cancels the first log. So I still have log x, wow, equals 10 to the 5th. You guys need some water or anything? All right, now we just do the same thing again. Everyone good with that? Same thing again. By the way, are you guys good with me just writing this? Instead of writing 10 to the 5th, we could do 1, 2, 3, 4, 5 zeros, right? 100,000. Okay. It's a little less confusing when I exponentiate again, because now I'm going to do 10 to this power and 10 to this power. That cancels the log again. And if you do try to plug this in, 10 to the 100,000th power, I don't think it works, so you have to leave it like that. I think your calculator is like, it can't handle it. It's too big of a number. I feel like you can't, yeah, 10 to the 5th to the 10 to the 5th. I don't think that's normal. I don't think we could do that. Don't do that. Yeah. All right. So this next one, we've got x to the square root log x equals 10 to the 8th. Solved by exponentiating or logging. So what we can do is log both sides. Why would I choose to log both sides? Yeah, it gets rid of the 10 on the right-hand side. It does two things for us, actually. So I'm going to go ahead and put my log, squeeze it into the front there. What can I do with this? Yeah, you can move it to the front, so that is helpful. So I have the square root of log x, and then I still have a log x here. On the right-hand side, this is lovely. This cancels, and I get an 8. All right, so this is where you gotta think about it a little bit. What do we know the square root is the same thing as what power? So I could rewrite this with one big set of parentheses to the 1/2. This is the same thing as log x just to the first power, right? It's the whole thing to the first power. So now, if you had x squared times x to the 3rd, what do you do with those exponents? You add them. So this is the same thing. I have the same base, even though it's a log x, and I add my exponents right here. So 1 plus 1/2 is 3/2. So you are allowed to do that as long as your parentheses go around the entire log, right? Don't do it if that 1/2 is only to the x. But since it's around the whole thing, you can do that. And then you can actually multiply by the reciprocal in the exponent. So this is a 2/3 to get rid of the 3/2. And we do the same thing here. We take 8 to the 2/3. So this can cancel, and I have just my log x. So I got rid of that exponent. by doing the reciprocal in the exponent. And you should be able to do this in your head. So you're taking the cube root of 8, which is 2, and then you're squaring it. So what do you get for that? 4. Right? Cube root first, then square it. All right, then we can get rid of this last log by exponentiating. And we get 10 to the 4th power, or that would be with 4 zeros, 10,000.